3.5, rational functions, graphs, applications, and models. When you see something that says rational functions, it's usually talking about a fraction. So a rational function they look at like this, but we're going to have some function on top and some function on the bottom, all right? So when we have a function on the bottom, a lot of the times we have to worry about that bottom equaling 0. And so when we think about our domain, we really have to worry about the bottom part not equaling 0. There's going to be something called an asymptote there. So we look at two graphs that we're going to see a lot today. We've got the reciprocal function, and then this one that I call the volcano function. You just look at the graph, it kind of looks like a volcano. The same rules kind of apply from the last lesson with the odd and the even. When I see 1 over x, you can think of that as x to the first. 1 over x to the first is an odd function. And so the same rules apply if it's a positive odd. If it's a positive odd, it's going to start on the low side and end on the high side, okay? Which is what this one does. This is a positive odd function. If it was a negative odd function, it would start on the high side and end on the low side. So it would look something like this, a negative reciprocal function. So we're just thinking about, is it positive odd or negative odd? Is this one's even, right? This one's even. And so, you know, the easiest even function that we're thinking about, normally end behavior looks like this, okay? Just think about it being up high when it's positive, and it would be flipped down low if it was negative, okay? Example 1, y equals 4 over x. I can see that as a positive odd function. X to the first power is odd. And so I immediately would know that it's lower on the left and higher on the right. That's what a positive odd is going to look like. Okay, it's increasing. And so I pretty much know what it's going to look like. Let's think about the asymptotes though. We know that that bottom right there can't equal 0. So x does not equal 0. That's going to be a vertical asymptote at x equals 0. Now also, if you think about it, there's no way for y to equal 0. It doesn't matter what you plug in for x. You can plug in anything you want. You just can't plug in 0, and you're never going to make y equal to 0. So y doesn't equal 0. That's going to be a horizontal asymptote. So picture what the graph's going to look like. We would know it's going to look something like this. That's not very accurate though, so we should probably, you know, plug in a few points and see. Okay? So if I plugged in -2, 4 over -2 is going to be -2. So -2, -2. If I plugged in -1, I'd have 4 over -1 is -4. -1, -4 is right there. All I'm doing is plugging it into this function right here. I can't plug in 0. I'm not allowed to. It's not going to work. It's not part of the domain. But I can plug in +1. +1, that'd give me 4 over 1, which is 4. I've got 1, 4. And if I plug in 2, 4 over 2 is 2. I've got 2, 2. I've got some points. And you can do as many points as you want, but that might be enough for us to know pretty much what this is going to look like. Right there. There's my positive and odd reciprocal function. Okay. Give the domain and the range for which it's give the domain and the range and the intervals where it's increasing, decreasing. Okay, domain. Domain, you need to look at your asymptotes, but the domain, remember, you squash it onto the x-axis. Everything's covered except for 0. So the domain is going from -infinity to 0, unioned with 0 to positive infinity. The range, squash it onto the y-axis, and it's the same deal. Everything's covered except for 0. So you might like saying all real numbers except 0. This thing is, notice if you trace it, it's decreasing, it's going downhill the whole time. The whole graph is going downhill. So there is no increasing, but it is decreasing from -infinity to 0. and then it jumps up to the top and decreases from 0 to infinity. Now, it's kind of a coincidence that this matches the domain. That's not always going to happen. Example 2. When you look at this function on example 2, what I see is I see a negative sign in the front, and I see x to the first, so I know this is a negative odd function. It's a negative odd function, and a negative odd function is going to be higher on the left side and lower on the right side. So it's going to look like that. Okay, so let's talk about the asymptotes. Again, the bottom can't be 0, so x is not going to be equal to 3. That's going to be a vertical asymptote. X equals 3 is not allowed. Now again, you can think about plugging numbers in, whatever you want to plug in. You'll never get y equals 0. You will never get y equals 0. So y doesn't equal 0. That's going to be a horizontal asymptote. So we already kind of know what it looks like. Kind of looks like this, right? It's going to kind of look like that. It's a negative odd as opposed to the last one, which was a positive odd. But we better be more specific, so that means let's make a table. I'm plugging numbers into this function. That's a little bit harder to do than the last time, but we can do it. Let's say we plug in 0. The function would say negative 1 over 0 minus 3 is negative 3. That's 1/3. 0, 1/3 is right there. Let's plug in 1. You'd have negative 1 over 1 minus 3 is negative 2, so that's 1/2. 1, 1/2 is right there-ish. And let's plug in 2. Negative 1 over 2 minus 3 is negative 1. That's going to be 1, 2, 1. Okay, I can see what this looks like. This is going to be something like that. And I'm not allowed to plug in 3. Can't plug in 3, but we can go to 4. We have negative 1 over 4 minus 3 is 1. That's negative 1. 4, negative 1. It's right there. Plug in 5. So negative 1 over 5 minus 3 is 2. That's 5, negative 1/2. Okay. I think I've got it. I think I've got a pretty good idea what this looks like. Like that. Okay. There's my negative odd reciprocal function. So we want the domain. Squash it onto the x. We're looking at all real numbers except 3. And for the range, squash it onto the y. We're looking at all real numbers except for 0. And as for increasing, decreasing, check it out. Over here, it's increasing because it's going uphill. It's increasing over here as well. It's increasing the whole time. It's going uphill the whole time. It's increasing the whole time. So we're going to say increasing from negative infinity to 3, unioned with 3 to infinity.